We are going to be modeling real-world situations with linear functions today. So that means we want to be able to take somebody's real-life problem and represent it with a math equation. So we're going to start simple here with Janine. She's got $450 in her savings account at the beginning of the year. Good for her. She places the money in the account at rate of $5 per week. That means she's saving. She's trying to save up for something. And she told herself, I'm going to put $5 away per week. We want to model this situation so we can show how much she's saving. And at any time, we can use a mathematical formula to figure out how much money she has in her account. So savings, S, and weeks, W. Well, the first thing we have to figure out is which one is the dependent variable and which one is the independent variable. Because remember, when we do a linear function, the linear function is y equals mx plus b. Except we're not going to use y and x. We're using s and w. So my independent variable is the weeks. Remember, you can never control time. Time is always independent. And how much I save is the dependent variable. So now if I were to rewrite this, my y would no longer be y, but s, because my savings depends on my weeks. So we have this equation here, S equals MW plus B. And they still mean the same thing. B is your starting point, or your y-intercept. So in this case, where did we start? How much money did she start off with? She started off with $450. Then every week, she wanted to save $5. So her $5 is her rate of change. Her bank account will be changing by $5 per week. And that will tell us her savings. So there, we just modeled this situation with a linear function. So if she saves for exactly 1 year, her savings are 5, well, W is going to be 52 because she wanted to save for a full year, plus $450 that she started off with. When I figure that all out, and you can take out your calculator to figure it out, 5 times 50 is 250, 5 times 2 is 10, so there's $260 here, plus the 450, so that gave her a grand total of $710. So her range was she started off with 450 and she went all the way to $710. That would be the range of this function. It says now as a question, why would it not make sense to evaluate S of 6.5? That means, why wouldn't we do this? Well, 6.5 represents weeks. So this means that she would be making a deposit at 6.5 weeks, but she's not. She's at the end of every week. She can't put money halfway in. She's putting $5 in once per week. So we wouldn't use 6.5. So the types of numbers that we would put in here would be whole numbers. And actually, not even whole numbers, because we wouldn't use 0. Does anybody know what it's called when you don't use 0? Right, it's called a counting number. Because we don't use 0 when we count. I like this one. I want to spend some time with Kirk here. Kirk's driving along a road at a constant speed. That means he's not going faster and then slower and then faster and slower. He's got cruise control on. He's driving directly towards Denver. He knows that after 2 hours, he's 272 miles from Denver. He hasn't gone 272. He still has 272 miles before he gets to Denver. And after 3.5 hours, he's 176 miles from Denver. We're going to want to model this with a linear function. This one's a little tricky to do, but let's get at it. First off, since it's a linear function, we want to have two ordered pairs. We've learned that all this chapter. How do you find the equation of a line? You use point, point. So one of his points was 2 hours, and he's 272 miles from Denver. His other point is 3.5 hours, and he's 176 miles from Denver. So D is the output. That's why the distance is in the y variable. And H is the independent. That's why it's in the x spot. All right, look what they're asking me to calculate now. I want to calculate the change in distance over hours. I want to interpret the slope or the rate of change. Well, the distance after 3.5 hours, they told me right here, is 176. The distance after 2 hours, they told me, is 272. And I want to divide that by my x values being subtracted. Oh, my pen's not cooperating. When I divide that out, I get -64. So do you understand what that means? It means he's closing in on Denver at a rate of 64 miles per hour. Every hour, he can take 64 miles off his distance because he's getting closer and closer. So that's what I just explained. Why is it negative? Because the distance is getting smaller. So let's say I were to do this right here. Here's his starting point. We don't know how far he was, and here is Denver. We just know that if he drives for 1, 2 hours, that this distance to Denver, he's still got 272 miles. But then if he goes 3.5 hours, so he goes another hour and a half, that distance to Denver is 176. So the distance is getting smaller, so that's why it's negative. Now we're going to write an equation, and this equation is going to be a little tough. So hang with me. We know a line is y equals mx plus b. Except in this case, we're not using y. It told us our output is d. Our distance equals our slope. We know we're closing -64 miles, and then they wanted me to use h for my independent, which is time. But where was my starting point? Aha, that's the trick to this question. How far away was I from Denver when I started this trip? Well, I'm going to clean this up a little bit, and I'm going to use this thought process that I used right here. Here's Denver. I'm going 64 miles per hour. So if I go backwards, at 2 hours, I'm 272 miles from Denver. But I've already been driving for 2 hours. Here's my starting point. And I just figured out I was going 64 miles per hour. So that means this first hour, I must have been going 64 miles per hour. And this second hour, I must have been going 64 miles per hour. And then I realized I have 272 miles to go before I get to Denver. So if I add all these three up, that's how far I was away from Denver to begin with. So my starting point was 64, and 64 is 128. And then I'm going to add on to that 272 more miles, because that's the distance I still have to go. And I must have been 400 miles away from Denver. So there is my equation. All right, so that's why I told you this one was a little tricky, because we had to figure out our slope. Sorry, not our slope, our y-intercept. We had to do a little bit of common sense and a little bit of drawing some funky pictures to figure it out, but we did it. And that was the answer to question E. How far was he from Denver? Show the work that leads to your answer. Well, that's the work we just erased. He's 400 miles from Denver. So after all this, how long is it going to take Kirk to get to Denver? Well, I like using my equation. And basically what I want is, if I do this for a second here, I want my distance to be 0, because this equation was telling me how long I am away from Denver. So if my distance to Denver is 0, that means I must have arrived in Denver. So if I solve this, bring this 400 over to the other side, and now to solve this, I'm going to divide it out. So 400 negative divided by negative 64. Now you guys are going to reach for your calculator, but I'm going to do this. I'm going to say 8 goes in here 8 times. 8 goes in there 50 times. 2 goes in there 4 times. 2 goes in there 25 times. 25 divided by 4, remember if I told you to divide by 4, you take half quickly. So half of 25 is 12.5. Half of 12.5, it should take him 6 1/4 hours to get to Denver.